Okay? Okay, so we continue with option pricing. Let's summarize a little bit. We got option pricing. Chapter 3 is the principles, which is the same as basics. Now we're moving to chapter 4, known as the binomial model. And binomial model works in discrete time. And next chapter, next time, is going to have what is known as Black-Scholes Model, which works in continuous time. In this discrete time, you got a finite number of, let's say, days. You separate into day 1, 2, 3, 4, 5, and so on. The last day is n. And in continuous time, it is continuous, okay? With continuous time, use the mathematical tool called derivatives. Day 1, day 2, day 3, we use these to be called, now, chapter 4, and we got chapter 4 is 0, introduction. We use what's called a period, and period is just a period of time. So period will be day 1 or day 2 or day 3, or the period will be week 1 or week 2 or week 3, or it's going to be month 1, month 2, month 3. So if it's time, if this is continuous time, this over here is going to be period 1, period 2, period 3, period 4, that's going to be period n. So we take a certain length of time, which we counted as discrete time, like 1 hour. Could be 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, okay? So that's discrete time. Discrete time has, the first primary characteristic is a period. What we're doing in here, binomial model, you also have a Black-Scholes model. And you got the basic of a model. So a model is a simplification or a simple representation of relationships in a system, in the economy, in a financial market. So a model will give you a simplified relationship. It's a simple or simplified, okay? And from a model, we're getting to a pricing model. And a pricing model is a relationship of how or what determines a price. How a price is determined. Or a different way of saying is what affects the price. And now we're going to be working on option pricing model. And we already discussed in a very simplified manner that an option pricing model first will tell you how the price of an option depends on other variables. So, you have a put, you have a call. We already specified some of the variables on which a put and a call depend on. Let's try again. So what does it depend on? A put and a call price depend on which variables?
Stock price.
On the stock price, we like to call it underlying.
Underlying.
Next one?
Exercise price.
Exercise price. Next one? Again?
Expiration date.
Time to expiration. Yes, time to expiration. Sometimes we can call it in finance maturity, when the contract matures, but maturity is used more for bonds and for debt, but it's still a maturity. What else?
Interest rate.
Yes, we already discussed the interest rate and volatility. So, from the principles, chapter 3, the principles, we know that these are some of the variables that determine the price of a derivative, or a put or a call. Okay? So we're going to be trying to be developing some formulas based on those. Okay? That's our goal. Before we just said, okay, if this goes up, this goes up. If this goes down, this goes up. But now we try to be a little bit more explicit. And from here, option pricing model, you got two option pricing models. The one is the discrete, and the other one is the continuous. Discrete is chapter 4, doing now. Continuous is chapter 5, doing next time. The foundation of a discrete model is the period, separating time into a separate, we say, unit of time, which we regard as a unit, as a period. Okay, and now we go to chapter 4.1. This whole chapter is the binomial model, okay? That's how we call it. The discrete is the same as binomial, which I'll explain in a minute. So, section 1 is one period. One period binomial. Are you zooming in? No? Or not zooming in? So, one period binomial model. First, In a binomial model, you have only two In a binomial model, you have only two outcomes. So we call it outcome. Sometimes we call it result. In mathematics and in statistics, we call it a state. We call it a state. In a binomial model, you got two states or two outcomes. Well, I don't have a coin. A coin will be represented by a binomial model. A coin will have only two outcomes, heads and tails. Okay? In a binomial financial model, which models the price, you will have only two outcomes, and the two outcomes will be up when the price goes up and down when the price goes down. And now it may seem simplification that if the current price is 50, it can go up to 51 and to 49, and that these are two possible outcomes, but later on we'll see that that's not really a major problem. We can generalize it in a number of ways, which I'll discuss in section 3 later on. So, in a binomial model, you got only two outcomes, up and down. And the second key characteristic is that we begin with a one-period model. In a one-period model, essentially, you are over here at time 0. So this is going to be t0 now. And it's going to have t1, which is expiration or maturity. Okay? So that's the only one. Later on, we'll extend it to 2 periods and see what happens. In other words, what happens if it's not a 1 day, if it's a 2 day? And then what happens if it's a 3 day? In other words, first, let's just see what happens, how to price it for 1 day, meaning 1 period, and later on we're going to extend in different ways. Okay, binomial, okay. So this binomial model, because of a state, is known as a two-state model without a dash over here. So it's a two-state model. In a two-state model, I already explained. The first one is t0, which is beginning of time, now. And then expiration is t1. Then you got U standing for up and D standing for down. U in finance is called total, or is measured by total return. Total return. And total return will be a number around 1. So U being up means it's going to give you a positive return. So U equal to 1.1 is the same as a return of 10%. And U equal 105 is the same as 5%, okay? So that's how we define it. And U equal to 101 is 1%, and U equal to 2 is how many percent? How many? How many? How many? 100%. 100%. So that's how we measure U on the upside. And on the downside, we call it D, is going to be a number between 0 and 1, okay? And if D equals 0.97, this means the return is minus 3%, okay? And if D equals 0.85, the return is like minus 15%. The example which is coming up later on page 99 for U is 103 is the following. S current price is 100. That's on page 99, so you can open to page 103. And then you say D equal, is it 0.8? D equal 0.8 and U equal 125. Okay? So, in a binomial model, this is given. This is just what the example is. So, right now, this is time 0. The price is 100. It can go up and it can go down. When it goes up, what's the new price? What's the new price? 100 and? How much? 125. This is the 125. You multiply 125 times 100. Okay? And then on the downside is 80. So that's how you basically measure it. Okay, so that's fairly straightforward. So the price will be respectively, so S1 will be either U times S0. So you multiply S0 times U, the return on the upside, or D times S0 on the downside. Okay? And if the price is, and if the price is 1, on the up it's going to be U, on the down it's going to be D. Okay? So this is actually S0. This here is S0, and this is S1 on the up and S1 on the downside, similar to over there. And now that we have S, we can do the call. We're going to focus on call pricing, and we can derive puts from the put-call parity. So focus on call only. So, what's the value of the call? Well, the answer is it up or is it down? If the value of a call on the way up at expiration will equal maximum of 0. And what was it? S1 minus x. Is it like that? Right? Is this what we had the last time?
Yeah.
Now, that will be the maximum of 0. And S1 is
US0.
is u times S0 minus x. So, you just take the maximum of the new price, the up price, and the exercise. We do now the same for D. Again, the call on the down will have exactly the same as S1 minus X. It has exactly the same value, exactly the same one formula, but now S1 on the downside will be maximum of 0, and D times S0 minus X. So if it goes up, this is the outcome. If it goes down, this is the outcome. Here, if X equals 110, if X equals 110, CU equals how much? For this particular option, if the exercise is 110, how much is the value of the option on the on up move?
0.
How much?
0.
It's 125 minus 110.
Oh.
Maximum of 0, and 125 minus 110 equal maximum of 0 and 15 equal to 15 if it expires on the upside, if the stock goes on the upside. On the downside is the maximum of 0, and this is some negative number, so from 80, okay, 80 becomes 80 minus 110, so it becomes maximum of 0 and minus 30, so it becomes 0. The option expires worthless. Okay? So, if it goes up, the option is worth 15. If it goes down, the option is worth 0 at a strike price of 110. Okay, the next part of the notation is R, and here in this notation, R is the risk-free rate. Risk-free rate. And now comes a tricky condition. And the tricky condition is that D1 plus R, and it's got to be U. Let's make sure. Yes, U. This is a little tricky condition. Okay? So, D, the return on the downside has to be less than the risk-free return. So, let me clarify this because a lot of people are confused about this. Let's clarify. If the risk-free rate R equals, let's say, 7%, okay? On the upside, you may get plus 10% return. And on the downside, you may actually get plus 1% return, okay? So, you are not losing money on the downside. You're not losing money. All you're losing is relative to the risk-free interest rate. You could make 7% risk-free, instead you took the risk and you made only 1%. Okay? So, it is very important that the D is less than 1 plus R. Okay? And it's very important that the U is above 1 plus R. Okay? Well, let's try this. Let's try this. U is less than 1 plus R. Well, what does it mean? U is less than 1 plus R. It means that if the risk-free rate is 7%, U is, let's say, 5%. Okay? So, your U gives you, on the upside, it gives you 5. On the downside, gives you 1%. But the risk-free is 7. This is impossible. It's a contradiction. No one will ever invest in a risky asset getting 1% or 5% risking when they can get for sure 7. So this situation here is impossible. It's important to understand. So this situation is impossible. No one will ever invest in an asset to get a lower return than the risk-free asset. No one will ever do that. There's no need to do that. Okay? That's a simple, we call it contradiction. It's a contradiction. So, U will always be above 1 plus R. Now, what about this? D is greater than 1 plus R. Is this possible? Oh.
No.
Same thing. Impossible. Think of it this way. Your risk-free rate is giving you 7%. On the upside, you get 20%, and on the downside you get 12%. So, your worst case is better than the risk-free. Well, this asset is always better, okay? So, this is impossible. You cannot have a risky asset that will always give you better than the risk-free, okay? It's impossible. No, you're going to invest in 12% and you can invest in 20%, and the risk-free rate is giving you 7%. They've been doing this with these real estate mortgages where they say, oh, the bank and the risk-free rate is 3%, but if you invest in these mortgages, you're going to get 8, 10, 12%. Well, that's impossible in finance unless there is also a risk which will make -2 or -5 or -7%. So this is also impossible. So you can't get this and you can't get this. So the return on the downside has to be less than the risk-free rate, and the return on the upside must be higher than the risk-free rate, whatever it is. Okay? That's so the D does not have to be a negative return. It could be 101, 102. It could be, but it has to be less than the risk-free rate. Okay, let's see what else we got now. Well, now we're getting to the concept of a hedge portfolio. So we discussed last time. What is a hedge? Anyone from last time? Hedge, hedge, hedge. What's hedging? Again, louder, louder.
Riskless.
Huh?
Riskless.
Risk?
Less.
Risk? Oh, less risk. So a hedge means reducing risk. Okay? So a hedge, to hedge means to reduce risk, to lower risk. Okay? So here a hedge portfolio is kind of like designing a riskless. In this particular case, is designing a riskless portfolio. And then we get the concept of, which I'll be explaining in the next 5 minutes. It's called the hedge factor or the hedge ratio. H or small h, large or small h. Okay, so let's see how we design it, the hedge portfolio. Let's make sure we get it right. It's got a H number of shares and a number and a call. So let's first write it out. What it has? It has H times S plus a call plus a call, okay? And this is S0. So this portfolio, when it goes up, will have H times, it's going to be US0 plus C, or H, it's going to be DS0 plus C. All right, let's see what else we got over here so that we can construct it properly. All right, let me make sure that we get this right. All right, now in a hedge portfolio, when the stock goes up, the call value goes up. So in a hedge portfolio, stock going up and the call going up, you will have the total value going up. But here's the trick now. If we design it so that the stock goes up and we short the call, when the stock goes up, the call goes down. So in a hedge portfolio, the call will be short. When you short a call, in other words, you sell a call, okay? When the stock goes up, the call goes down. Or when the stock goes down, the call goes up. Okay? So in a hedge portfolio, if you want to lower the risk, okay, let's try to do this. Let me write to do this to make sure it's very simple to understand. So you got a stock plus call results in risk going up, increasing. In a stock minus call results in risk going down. Is that part fairly clear so far? So, when you go long the call and long the stock, you're increasing your risk. When you go long the stock and short the call now offsets. Stock go up, call go down. Stock go down, call go up. The risk overall goes down. Okay? And now comes the last piece. Well, can we design a portfolio which essentially expires and has the same value on the way up and the same value on the way down? Okay? So here we're going to have minus call, and here you got minus call. Okay? And now let's see what happens. Let's do this. So, the value of this portfolio, value of our portfolio, which is H times S0 minus C, okay? The value, if it goes up, will be equal to H times U on the upside times S0. And then you have the value of the call on the upside. Call U. So, we determine that here is, which is designed, call U is the value of the call if the stock goes up. And here, D will be H times D times S, this got to be S0 minus CD. Okay? Is this fairly clear so far? This part clear? What's everyone like? Is it fairly clear? So, the value of the portfolio is simply this. H times the share minus the call, shorting the call. If it goes up, it becomes H times US0, and the call at U, and this one is HD minus D. Okay. And now we do a trick. And the trick is the following. We choose H so that when it goes up, the value is the same as when it goes down. So, a hedge portfolio is a riskless portfolio, and the definition of a riskless portfolio is that the portfolio has the same value whether the stock goes up or the stock goes down. So, in a riskless portfolio, the value on the upside equals the value on the downside. Okay? So, a portfolio is a hedge portfolio when, whether the stock goes up or the stock goes down, the value remains the same. So the value of the hedge of this equals this. Okay? So now here for the value of up, and this is the value of down. And now we can do a little trick. We can say that VU equals VD, and ask what is H, or what is the H that will make VU equal to VD? That's the question. What is the H which makes VU equal to VD? Well, let's solve. H, U, S0 minus CU, this is VU, equals VD, equal H, D, S0 minus C, D. All right, this part here is VU equal to, this part here is VD. And now we calculate for H. We take this one here, it becomes H times S0 times U. This one comes here minus D equals CU minus CD. Okay? So, H will be, you have CU minus CD on the other side, CU minus CD. Here you got U minus D, U minus D. And we need one S to make sure that we're okay. Here is the S times S. A different way of saying it is CU CD equals SU minus SD. Okay, so now this is not in the book, but it's got a very, very, very good interpretation. CU minus CD has got an economic, is a logical meaning. The difference between the value of the option on the down and the upside. This is the difference in the value of the option. And we use it in economics and statistics, we like to use delta. You're all familiar with delta? Delta meaning difference. Okay? So, H becomes the difference in the value of a call. So, when the stock goes up and down, is the change in the value of the call. Well, what's this here? SU and SD. SU is the stock on the upside. SD is the stock on the downside, is the difference in the change of the stock. So this is delta S. So the hedge ratio tells you how much the value of the call changes when the stock changes with $1. When the stock changes by 1 unit, how much changes the call? And now we need an example with a calculation here. The calculation here is, question is, for our example over here, for this example over here, the hedge equals change in the call to change in the stock. How much is the value of the call changing? In other words, here you have CU minus CD. Call on the up, call on the downside. CU equals 15. CD equals 0. So the change in the value of the call is 15. And how much is the change in the stock?
Stock is
The stock price changes from up to down. This is up, this is
45.
down. The difference is
45.
45. So, here the hedge ratio is how much? 0.33, maybe 0.34, okay? So 0.33 is the hedge ratio. Now, what does it mean 0.33 is the hedge ratio in our particular case? What's going to be the portfolio look like if H is 0.33? How many stocks and how many calls? So our V portfolio will be of, let's say, 100 calls and how many stocks? How many stocks? 33. 33 stocks. And the calls are short. So, if you want to hedge your stock, and here it is, notice with an exercise, remember I put in exercise at 110. You'll need 3 times more calls than you have stocks, okay? I think they got an example over here, but we got to see what's the example of the strike price. Okay, now let's do exactly the same example as in page 99, meaning you open on page 103 and calculate the same example with the numbers are the same, but the exercise price is 100. So, calculate exactly the same when X equals 100. Okay? So, when X equals 100, first, CU is how much? What's the value of the option when exercising at 100? And it ends on 125. How much is the CU? 25. How much is CD? 0. Okay. So, what is the hedge ratio? The hedge ratio is the difference, the change in the value, which is 25 minus 0 is 25. And what's the change in the price? The change in the price is
45.
45. So what's this number like? 0.6? What does it tell? What is the number like? 0.556. Oh, so now you see something very interesting happening. If you have, in this particular case, you will have 100 short calls, and you will have 55 shares. You see? So your hedge portfolio will have 55 shares if your strike is 100. But if your strike is 110, you're going to have only 33. Okay? So, which call, or how, with the hedge ratio, see which one's got a better value. You got a better or higher value when the strike is lower. So when the strike is lower, the call gives you a better hedge. Okay? So a call gives you a better hedge as you move at the money. When you move out of the money, you need more calls to hedge a stock. Here, for one stock, you need to hedge one stock, you need 2 calls. All right? And here, to hedge one stock, you need how many calls?
3.
3 calls. So, you see, as the call becomes more out of the money, you need more calls to hedge the same number of stocks, okay? As the calls become more and more in the money, you need less and less calls to hedge a stock, okay? So that's a very important property. And now we need one very fairly complicated piece, which is very tricky, and I don't know if we should go into deriving it, but let's try and write out as much as we can over here. Is try to get this as much as we can. Is the following. So let's try and get this whole thing to see how we can do this. So first of all, let me copy the first one. Is that H equals CU minus CD divided by US minus DS. Okay? This is kind of like the same as delta C divided by delta S. So that's the one piece. Now here's the second piece which we have. If you have a riskless portfolio, the return on the riskless portfolio should be 1 plus R, the risk-free rate, plus the initial value. So let's try to do this. V U should equal to 1 plus R times V, the initial value. So VU equals V times 1 plus R. So this is the present value of the hedge portfolio. So the present value of the hedge portfolio, and this one, the U, is the future value of the hedge portfolio. Okay? And the difference between the present value and the future value is that the future value is the present value times the risk-free rate. Okay? You studied this elementary finance, right? So you take the present value, you take the risk-free return, you get the future value. So you got the present value of the portfolio, give it the risk-free rate, you get the future rate of the portfolio. And now we need to do this. We try to substitute VU and see what's VU like. So VU equals, let me see where I got it over here. This is the VU over here. H times U S0 minus CU. So you got H times U times S0 minus CU, okay? So this is the VU part. Now let's see what's the V part. Equals 1 plus R. And now let's see what we get for the V part. For the V part, we got here's the thing. H times S0, H times S0 minus the value of a call. I just copied this one here. H times S0 minus call. Okay? So, this is H times S0 minus call. Okay? Is that part fairly clear? So, for the V, I copy this part. For 1 plus R, I just copy 1 plus R. And for VU, I copy this part. And now we have a lot of computations. We got a lot of computations because we need to derive something, okay? So we now start moving in here. So we got HS. Let's see to make sure that we got this right. For the value of H. Oh. The value of H, we now substitute. That's the tricky part. Do you guys see what happens here? This is H. Okay? So now we start substituting for H here. Becomes CU minus CD divided by US minus DS times U times S. This is the same as S0, okay? This is this part over here. Then I got minus CU equal 1 plus R. And then again, you gotta copy. H becomes CU minus CD divided by US minus DS times S0. And then I have minus C. And now we continue a little bit. This S0 with this S0 with this S0. So it turns out that the current stock price doesn't matter over here. And here, same thing. The current stock price doesn't matter at this point. Okay? So now we're moving on to derive a few things. Let's see how we're going to go about it. I just want to make sure that I get this right. We got CU minus, well, let's just copy first. CU minus CD, U minus D minus CU equals 1 plus R CU minus CD divided by U minus D minus C over here. Let's see what's a good calculation over here. So 1 plus R C. Okay. So here's the thing we're going to do. We're going to take the C out and move the C on this side. So this C plus 1 plus R becomes 1 plus R times C. Okay, that's 1 plus R times C. C is the value of the call now. Okay, and then we throw everything on the other side. So what we want to do is get the call on the one side, the present value of the call, the current price of the call, and take everything on the other side. So I take the C on this side, 1 plus R, and then I do the rest. And what's on the other side? On the other side is CU minus CD, CU minus CD divided by U minus D. Okay, so that's on, oh, it's got to be a minus sign here. Okay, that's a minus sign.
What happened to the U?
Which one?
In the line above that, you see you got CU minus CD over the line above. You got that U between.
You mean here?
No, above in the second line. In the line above that, yeah.
Okay,
that
CU
line,
minus CD is remained.
Right.
U minus D remains. S0 is cancelled.
Where's the other U?
Here, minus CU.
But you got U.
not
That's like U.
S0.
Oh,
In front of S0.
Before the S0, you got the
Haven't
U.
you?
Oh,
Yeah.
I forgot the U. Okay, I forgot the U here. Okay. Okay, that's a good one. So I forgot this U here. Okay. So now we got this times, it's going to be U. It gets very complicated, very unpleasant. But we gotta go through, well, try another 5 or 10 more minutes to go through it. So U times CU minus CD, U minus D, this is with a minus sign. Then you got this CU becomes plus CU. So this comes over here. This goes on the other side with a minus sign. This CU goes on this with a plus sign. And then you have plus 1 plus r, and then you have cu minus cd, u minus d. And did I miss here the same thing? No, that's okay here. Cu minus cd. I can check to see, maybe I missed it, maybe not. Okay, so cu minus cd, u minus d, 1 plus r. Okay, here plus cu, and this is cu minus cd, u minus d times u, and this is a minus sign. Okay, and now we continue. Maybe I should just go over there on this side to continue. It's got a few more steps, 2 or 3 steps to get finished. All right, so we got 1 plus r times c. Let's see what we got now on this side. You got here u minus d, and this is u minus d. So we take 1 over u minus d, and when you take 1 over u minus d, you get u c u. So I'm taking this piece, I'm taking out. You got UCU minus, it's minus UCU. Then you have plus UCD plus UCD. So we got this part. This CU becomes U minus D plus u minus d, and for this piece becomes 1 plus r plus 1 plus r cu minus cd. And now we got a lot of things to do. So I got the 1 plus r, okay. Got the c, I got 1 minus d, okay. And now I just pull up all the cu on the left and then the cd and see what happens here. So when I take all the cu, becomes u minus d. And when you take all the cu, okay, you got here minus u, okay, you take all the cu's, you get the following. Cu becomes 1 plus r minus d. Divide by, here's u minus d, u minus d, and then you have cd, and the cd becomes 1 minus r minus 1 minus r, cd becomes minus 1 minus r minus 1 minus r plus u. And yeah, it gets very, very complicated. And now this u minus d, I'm going to move it over here. U minus d becomes here u minus d, and here becomes u minus d. And what happens is that now that this whole thing we're now very complicated. That's what's really nasty and unpleasant about derivatives. You got a lot of calculations. And now you got this P, which is 1 plus R, 1 plus R minus D, divided by U minus D. So when you use this one, it becomes the following. This becomes CU times P, and then this becomes plus CD 1 minus P, and we got here the division of 1 plus R. So what we did was the following. We just take the C on the one side, okay? We took all the CU and all the CD on the other side. We know what's U, we know what's D, okay? So I take the C on the one side, I take the UC and the DU on the other side. I collect the CU, and the CU turns out to be, the factor is 1 plus R minus D, U minus D, which turns out to, when we put it as P, it has a meaning of probability. So 1 plus R minus D, U minus D, just simply becomes P. And this one is minus 1 minus R minus plus U. It's got to be plus U over here. U minus D becomes 1 minus P. So finally, we get to a little bit interpret what's going on. What's going on is that the value of the call will be here's 1 plus R. So I take 1 plus R, okay? And this 1 over 1 plus R is the present value of the probability of the call going up plus the probability of the call going down. So if there's a 40% chance to go up and 60% chance to go down, you multiply by the values. So this piece over here gives you the chance or the probability of going up. Okay? It sounds like complicated math, but that's the chance of going up. And this is the chance of going down. Okay? And that's basically the formula. Probability of the call going up plus the probability, which is 1 minus P, the probability of the call going down. So P gives you the chance, the probability of an up move. This is the other probability. 1 minus P is the probability of going down. And then CD. And now let's calculate, for this example, the value of the call. The value of the call. All right, so we need to calculate here P for this example. So first of all, for this example, we say, for this example, CU equals how much?
CU 25.
Is 25. CD equals
0.
0. And now we need to calculate P. So, what's the calculation for P?
And
1
plus R.
plus, well, what's the example R here for the example? R is 7%. 7%. So 1 plus R is 7%. 0, 0, 7. And D, what's D?
D.
On the downside,
Downside.
0.8. Okay. And this is the difference between U and D. The difference between U and D. What's the difference between U and D?
0.4.
0.45. So it is 125 minus 0.8. Okay? So this one is 0.45. Okay? That's the one. And what's on the upside? Is it 27? 0.27?
0.27.
0.27. So, anyone with a calculator, 0.27 by 0.45? 0.27 by
0.6.
huh?
0.6.
0.6. So, 0.6. Okay. So you got a point. So P is 0.6. And now that we got the P, we need to calculate C. So we got the CU, we got the CD, we got the P equal 0.6. Now we move to calculate C. The call of the option will be 1 plus R. In other words, the present value of what? 0.6 times 25. Minus
0.
plus 0. All right, someone with a calculator, how much is 0.6 times 25? 6 times 5, 30? 15? 15 divided by 107. So what's the present value of 15?
14.
I think we need to see how long is the option. Is it 1 year? Because here, that's R, but that's for 1 year, right? So we need to check that part. So how much is it?
14.
14.02. Is this what the answer is there or not?
Didn't.
Wow, this is... you all looking at page 103? You open page 103? Is it the same number? We got it? So, call equal to
probability ครับ Binomial คำนวณมาจากแบบนี้
1402. You guys got it?
Okay.
So, with the first step, we got the U, we got the D, we got the probability, we got the value of the option on the upside, the value of the option on the downside. So basically, what this tells you is the weighted average of the upside times its probability, plus the downside times its probability. All right, 10-minute break.